Welcome to Go Get It. Before we start today's topic, I would strongly encourage you to explore our videos on relations and functional dependencies, which is shown above. Today we'll see different types of dependencies. To start with, we'll start with full dependency. A functional dependency is called as full dependency if and only if the determinant part of the functional dependency is nothing but a candidate key or a super key. To understand this, we'll consider the given relation here. We have a relation with attributes S, T, U and V, and these are the functional dependent sets. S derives T, T derives U, U derives V and V derives S. Here you can see that S, T, U and V are the candidate keys as they derive all the attributes of the relation. To understand what is candidate key, I would encourage to watch the videos on keys and closure, which is marked at the top of the screen. Now, as I said, S, T, U, V, they derive all the attributes of the relation, so they make the candidate key of the given relation. So, diagrammatically, if you see a full dependency, here you can see that as S, T, U and V are the candidate key and these are on the part of determinant. So this functional dependent is full dependent. This is also full dependency, this is also full dependency, and V tends to S is also full dependency. So to remember, you can remember the diagram where the determinant part should be a candidate key or a super key, and the dependent part can be anything. It can be a prime attribute or any non-prime attribute. Next comes partial dependency. A functional dependency is called as partial dependency if and only if. Here we have constraint on determinant and dependent too. Determinant of the functional dependency, it should be a part of the candidate key. Mind well, here we have told it should be a part, it should be partly a candidate key, and dependent part should be a non-prime attribute. For instance, the relation here is A, B, C, D. A derives C, B derives D. Here you can see, you calculate the candidate key as AB. So AB is the candidate key because you can see AB combination derives C and D and AB, so that makes the candidate key, only candidate key for this relation. Now you can see as AB is a candidate key, so for partial dependency to be valid, we need to have determinant as a part of candidate key. So part of candidate key means AB. So part of candidate key of AB is A. Part of candidate key AB is B also. But AB, it makes complete candidate key, which is not valid for this partial dependency case. So we'll consider only the partly candidate key. So A derives C, and the dependent part, as the definition says, should be a non-prime attribute. As AB is the candidate key and C and D makes the non-prime part of the key, so A derives C means part of candidate key derives a non-prime attribute. Here also, so this justifies the definition of partial dependency. Again, here also B is a part of candidate key and D is a non-prime attribute. Again, it justifies the definition of partial dependency. So to remember again, you can remember by using this diagram. The determinant part should be a part of candidate key and the dependent part should be a non-prime attribute. Next is transitive dependency. A functional dependency is called as transitive dependency if and only if. Now there are two cases in case of transitive dependency. First case says that the determinant part of the functional dependency should be a non-prime attribute, let's say denoted by NP, and the dependent part of the functional dependency should also be non-prime attribute. Now second case says that determinant of the functional dependency, it can be a partly candidate key plus non-prime attribute, and the dependent should be a non-prime attribute. Let's take the example of the given relation here. We have functional dependencies as A tends to C, B tends to D, BC gives D and C gives D. Here again, after calculation, we found that AB is the only candidate key as it derives all the attributes of the relation. Now, diagrammatically, if you see, the non-prime attribute should be on the determinant side, and again the non-prime attribute should be on the dependent side. Now let's apply this definition on the given functional dependent set. As I said, AB is the candidate key here. So let's first justify this diagram. So we have C and D as non-prime attribute. So we'll find C here and here. We have C as a non-prime attribute on the dependent set and D as the non-prime attribute on the dependent set. So this functional dependency justifies the diagram shown here because C and D both are non-prime attributes here. Now let's see the second part or the second case. We have part of candidate key plus non-prime attribute, and on the right hand side we have non-prime attribute, that is dependent part should be a non-prime attribute. Let's again justify using this given relation. So we have AB as a candidate key as said earlier. So part of candidate key is A, which derives C is a non-prime attribute, but this justifies the definition of a partial dependency. Now let's see B and C derives D. Bingo! B is a part of candidate key and C is a non-prime attribute. D being a non-prime attribute, so this functional dependency set justifies the second diagram, which contains dependent as non-prime attribute and determinant as a partly candidate key and non-prime attribute. So these three dependencies are the most important dependencies which are very much important and helpful in determining the normalization parts. So for first 1NF, 2NF and 3NF, we need all this dependency knowledge. There is one more dependency which is called as overlapping candidate key dependency, which we will discuss in the later videos. I hope this video has cleared or distinguished the difference between the different dependencies, that is full dependency, partial dependency and transitive dependency. Thanks for listening. Keep watching.